Hello dear students, today we're going to do an experiment on Atwood's machine. It was invented in 1784 by George Atwood. The clever principle behind the Atwood's machine is still widely used in places where a repeated heavy lifting and lowering of the same trajectory is required, like ski lifts and elevators. Initially it was used to measure the acceleration of the free fall. With our digital sensor we can get a very precise reading of our velocity and acceleration. Something like this would not be possible a century ago. The idea is simple. As the acceleration is large and the mass falls fast, something should be done to make it fall slower so that the accurate fall time may be measured. Apart from that, notice that because of the initial balance of two loads, if we were to raise the heavier load, we would only need to do work on the mass delta between loads, not on the whole load. Similarly, when an elevator is carrying people, it is spending energy on lifting people, not the whole elevator, since the elevator's mass is balanced by this load called counterweight and doesn't require additional energy expenditure. Again, before we start, we remind you that this is not a substitution for the manual and some parts are left out. The experiment consists of two parts, a mass wound on a pulley string and the Atwood machine experiment itself. The setup is following: pulley, string, rotary motion sensor, mass set and mass hangers. We will log in on our computer and then open Data Studio. We're going to record the acceleration of the mass m2 and m1 as they move up and down from a velocity slope and as the mean of the acceleration. So we will select two graphs. We set the sample rate higher because the first part of the experiment requires rapid measurements. In rotary motion sensor settings, make sure that large pulley is selected. Now, for part 1 we will be simply letting different masses drop and unwind the string and measure their acceleration. We measure the mass of the loads we will be using as well as the mass hanger's mass. We tie a string from the inside of the pulley and cut it from another end. The length is such that when we attach a load to the string and fully unwind the string, it will hang very close to the floor. Then we tie a mass hanger to the string and check how low it will be. We use the rotary motion sensor that is connected to the computer to record the data. First we drop 10 grams, which really is around 15 grams instead if we count the mass hanger's mass. We'll record the screen of the computer to show you how to accurately analyze the data. As you can see, we only select a certain region of the data where we have a nice smooth slope. This is the moment of the fall of the load. On acceleration graph it's much harder to see where that period of fall was happening, so we'll use the same time frame on the acceleration graph as we did on velocity graph. Then we do 3 sets of 20 grams and 1 set of 30 grams. For part 2 we're doing the imitation of Atwood's machine. Across the pulley here we have a string, and then on the end of the string we have 2 mass hangers. Each mass hanger has 200 grams on it. Right now they are balanced, so the system is at equilibrium. The mechanics of this experiment is really simple. What we will do is we will add some masses to our hangers consequently. So now we are creating mass difference, and then mass m2 is heavier because of this. It starts to fall down. One thing to remember is before the mass here M2 reaches the ground, you need to stop the movement, otherwise the mass hanger can break from the fall. We should repeat the same process several times for 20 grams delta. Then you're going to find the average acceleration. The best way to do this experiment is to work as a group. So one person is going to run the computer, another person is going to run the experiment. However, here we don't have enough people for that, so LA Kairan is doing everything by himself. Furthermore, we will collect all the data in Excel file and upload it with the video and manual, so you can take this data and do your data analysis and write your report easily.